want to capture this moment because we were chatting, hi everyone, about things that happened recently to us on our mobile devices. I was saying that I updated to iOS 26, and as much as I love this device, this looks like now like candy bars and like things wobbling for no particular reason. And icons that are like not crisp anymore. And so I'm pretty unhappy with the result. And Thomas was telling me about what happens on Android land. No better.
Yeah. Software
Yeah.
updates.
Yeah. So don't update your mobile devices. Yeah, that's the bottom line. If you're happy with what you see, just cling to it like it's gonna go eventually because it's gonna go eventually. So, hello, Thomas. So,
Hey, Luca.
yeah, I'm very excited about today's episode. Well, first of all, we're getting closer and closer to PyTorch conference, and we'll both be there. A lot of events that week. So yeah, pretty excited about being in SF and being around friends from PyTorch. It's always a nice moment. It's like nice time of the year. And then Thomas, you will also be able to participate to the GPU mode thing, right? In person, in real
Yeah,
life.
I hope so. Like the company didn't book the flights yet.
Oh
Uh,
yeah, you should you, you
but
should
then
ask.
I heard that more important people than me don't have the flights yet either.
Okay.
So
Oh, okay. That's good. That's good. All right. So anyway, that's getting closer and closer, and so we found ourselves wondering, since we are doing a lot of work internally, using Thunder around Thunder, um, and we asked ourselves how to best. mm, I wouldn't say pitch, but almost pitch Thunder this year at the PyTorch conference because we've always like described what it is and what you can do with it in terms of mechanisms because it's kind of a concept that is not it's unlike other things on the market, and we believe it fills a void. But of course, as anything that comes early, and I've been unfortunately experiencing this in the past. Um, it takes a while to people to warm up to certain new ideas unless they become hype and then everybody warms up immediately. Um, and like the way we describe it to ourselves internally is it should become, or it is, or it's in route to be a very like the Swiss Army knife for um, dev techs, and dev tech is a role that is there at NVIDIA, or optimization engineers here at Lightning, for example, which are like the parallel, which are people who receive a workload and need to make it fast. And this is a broad thing, but it's something that is happening in the market. Like, holy, like, there's so much hunger for someone who, takes something and makes it fast because people develop new models or develop new services, and now they're confronted with the fact that either the service is not fast enough for users to get a good experience, or they are spending too much and their GPUs are like often idle or not fully utilized. And so they know that, people are reserving hundreds of thousands of dollars of compute or more, and they know they're throwing some of that in the garbage because their workloads are not optimized. So it's becoming there's not a whole lot of people who can do this work. Here at Lightning, we happen to have people that can do this work, and this is also why people come to us. But you need the tooling to do that. And sometimes you don't have the full spectrum of the tooling. And some part of the tooling we have is Litzer, which is again, you can't compare it with PLLM or SGLang, which are very overfit for LLMs. But if you need to serve anything else of a moderate complexity, it's really extensible. It kind of follows this principle of being, out of core extensible. So you can write custom loops for it. You do stuff that is non-trivial to pull off. if you build it from scratch, for sure, it will take you several weeks to do that if you can do it, or with more kind of monolithic things where you don't have control, or it's very hard to go into. And Thunder is the same thing when it comes to the model level. And sometimes these two things are so tightly intertwined together that you cannot take one apart from the other. And so what we wish for users to do with Thunder is use it as a way to see the computation, measure it, optimize, and so on. And so it becomes a tool for like experts or moderate experts or people who want to optimize their workloads in a way that doesn't get in the way, in a way that enables them to do this job. So it's not something that you just apply and boom, magically you get faster. There's Torch compiled for that, which is amazing, by the way. Thunder is a kind of a different animal. It allows you to go through something that hasn't been done before in a way that it doesn't feel like going through a hole of this size and coming up on the other. Anyway, in the spirit,
when I smarten up, I want to like make a career out of optimizing things too.
Yeah, well, and so the nice thing about it is now that like we spend, or we in a general, in this very general sense, spend time this week doing something that, as Thomas always says, is not optimization if you can measure it. And we've always showed profiling and measuring, and then doing some Thunder thing, and then profiling again. But what if we provided a way to profile within the trace using a transform to know what to profile and to make it super frictionless to say, okay, this is my trace. Can I decide what to profile where? So now to me, profiling and optimizing are something that I can iterate super fast with. And yeah, so the surprise for this episode is like what Thomas has created, in this direction. So Thomas, the stage is yours.
Yeah, so thanks, Luca. And we need to have like some soundbite that lends itself to the clip. But we will look right into the kitchen where the sausage is made. And let me find the right Chrome window to share here. Yeah, this one. So here we are. A blank notebook is something where nothing bad happened. And let's first look at why we're doing that. And to have that, let's do a very simple thing. So we get Torch, Thunder, and because we need some model, we also get libgpt. And warnings. And so I'm in one of these studios, and it's a fresh studio, so I didn't install Transformer Engine yet. But okay, this be as it is. So we get some model on a device. So let's say on the CUDA, and we take libgpt GPT from name llama 3.2 1 billion. And I don't need any gradients, and I'll set the max sequence length and initialize the KV cache. But before I do that, for demonstration purposes, let's make the model small. So I will delete most of the things. That should give me something, right? And now I can thunderize the thing, right? And if I have some input, let's say some tokens, so I'll just use random tokens today, 5 of them, and those need to be integers. And I also need, for inference, we always provide the input positions too. And so this is just a range 5, which is automatically an integer, and we put it on the CUDA device as well. And now I can run jm imp input pos. And this is, of course, as you know it, and we've done this many times. So the question is now, how do I profile it? And so Torch has the PyTorch profiler, which I personally think is very cool. And I always use it with stack equals true. And then I can run, and I need to assign it a name to access it later. So jm int input pos. And now I can, of course, look at the trace. So if I write prof export home trace, and I name it trace JSON, which is like test and trace JSON are the best names for everything. But if I download this, I can open a new tab, and there is the standalone tool too, but I always use the Chrome trace thing here.
Perfetto tool. Yeah. I kind of like Perfetto. It's not bad, but it's exactly.
Yeah, I think I tried to get it to run once, and it didn't work the instant I looked at it, and then I was out of patience or something.
See, this is the important part of building products. 0 to success needs to happen in like the first 2 seconds. Otherwise, you're done.
Yeah. So I see that I have all these kernels here, and they're great kernels, right? NVFuser, point-void kernels, some Cutlass FMHA sounds like it's a flash attention style thing or so.
Yeah.
And I can see, of course, here's the Thunder computation, and that calls all sorts of things: NVFuser, Linea, alias. But so what's really going on here is a lot less clear. And even if I zoom in, let me try to. Yeah, if I zoom in, I see that I get this as one big block, the Thunder computation, and then I can imagine that there are various things here. But if I want to go back to my trace and I go Thunder last traces, and I take the last one, the one that's actually executed, I can map this now, right? I can say, okay, here we have the NVFusion 0, and there will be an NVFusion, here will be a Linea. But so this is like the second best, and we thought that, well, maybe we can make it even better. And have a clear
because ultimately, mapping. Because ultimately models are large. And so this is a small one because we reduced it, but the best you can do right now is to get a full trace for a full thing, and then a full profile for the full thing, and then you need to manually go and say, okay, this is that, this is that. It might not be always like super quick to do.
Yeah, and also you imagine that the NVFuser pointwise is in the fusion, but for example, would you know like what the smaller kernels in the back? So those are a lot of fusion kernels, right?
Yeah.
But so if we look at the later kernels here, so there's
what is that?
SGEM, and so which ones are these really, right?
Yeah.
And so we want to map it back to the Python code and also back to our Thunder trace. And we can do that now. And it's a gross hack, but so there is in Thunder everything is a transform. So
I thought in Thunder everything is a growth hack. No, it's everything is a transform.
yeah, and we can look at the transform after and the juicy details after we look at the. Oh, now it's all called profile transform. So call that p transform, and that's profile transform dot profile transform, and you can pass some parameters if you only want to profile part of it. But so
we'll look at that later.
Yeah, Thunder JIT, and it's not fancy yet. It's just indices into the trace or into the bound symbols.
Yeah, but we could improve it, right? We could have like a function or something, yeah, to make it more.
Yeah, I would probably look at like you specify some name and then you get the first name that is.
Or exactly from here to here. But let's go through it and then we think about the future.
Okay, so we JIT the thing with our transform, and because the first iteration is a bit special, it does warm up, and so we just send the input through it a couple of times, or 5 times to be precise, and then it will run as usual. But then we can do a trick and we can grab the profiler, because the profile transform did it for us, the profiling, and we can get the profile and export the Chrome trace. And this could be trace JSON too, or maybe we call it test JSON. The other good name.
Exactly.
And download, you see that's the 18th time I download, or the 19th time I'm downloading this JSON, but that be as it is. I will open it up here in the developer tools as well. And here we are. It looks basically the same. But if you open the Python, we have now, and this is like the end of the profiling.
Yep.
But here's what's going on. And what I did here is I introduced an extra layer that basically in the stack takes the trace apart and makes it all single lines. So this is NVFusion 0, which is the 17th symbol. And you see the line of code that generated this part. And this is all the things it calls, right? So it calls.
Perfect. So basically you have the whole trace in that line, you have the whole trace. And then you see the things that are called from that trace entry.
Yeah, and then on the GPU, I can also look at what's happening, and I need to zoom out for that again, because it's all at the very end. Wherever there is nothing before this. Okay, maybe something is still up, but I think that those are not my errors here. Okay, so you see that there's the lines of code again in the stream 7 trace, but something happened that we didn't get the other bits, which is unfortunate. And it wasn't there when I tried it. Let me run it again.
Yeah, so you understand how fresh this is, right? But I think from that glimpse we can imagine what happens with the others, but let's maybe rerun it and see if we're luckier, and then we'll release it
Yeah. So
when it's fixed.
before the thing is the programming, and afterwards it's the debugging, right?
Yeah,
So what we should have seen is that we have here we have the line of code, and that matches, of course, the thing here in the.
oh, okay. So you have two lines instead of these are not two streams. This is the same stream with two bars, and one is the trace and one is the kernel.
Yeah, so the PyTorch profiler has this register or record function thing, and this basically adds a thing here that marks all the kernels that come from it. So this
Yeah.
is the part that comes from the NVFusion 0. This is the
Oh,
part that
wow.
comes from the
Geez,
Linea.
this is
And so
super convenient.
you
Yeah.
see like which kernels come from which line of the trace.
Yeah, which is the whole point when you do this kind of job, right? Like you pretend your trace, the CPU trace and GPU trace are ideal. The reality of things is that you would wish you would know where the heck that kernel comes from all the time. This is something that your brain learns how to interpolate. And now we have it in front of us. Like it's amazing.
Yeah. So let's see if
Almost all of it. Almost all of it. But barring completing the work. But yeah, that's
yeah.
super helpful.
So let's see if rerunning helped. So there is some jitter in the profiling.
Yeah,
Yeah, now it's perfect here
yeah,
again. And you see, and now these are like running very, very tightly too,
yeah.
which is neat. And you see there's some modicum of
Oh, look at that. The torch
and,
index copy that runs the mem copy device to device. How cool is this? Yeah, I
right.
like this.
Yeah, so this is this is what we did. And you can also look at the trace with the profile transform, of course. Let me make this a smaller trace. So if I do Thunder last traces JM,
Oh, yeah.
and you see now that there's the
Yes.
start profiling here,
Yeah.
uh, which is new. There's the NV Fusion and all these lines, and it's a bit shorter because we dropped all the subsymbols
Yep.
uh, here. But then there's the end profiling, and you know that it's like exactly between here and there that
Yeah.
we ran the PyTorch profiling. And so, and the other thing is that all these things here are like ad hoc symbols. It's a trick that I stole from Xidich. And the debugging transform that I think we saw a while ago too.
Yep.
Um,
From
and
him, I
so
think still.
the curious thing here is that all this only takes like a few lines of code, and it's really simple.
Yeah.
So the entire thing is like less than 100 lines.
Yeah.
And the thing is that it's like a huge Python hack. And basically, I take the Python line because traces are all like straight line programs. I can take a single line and it will be a function call. And so I make a function here that only does this one line of code as a separate function. And then I modify the name because the name will be what the profiler picks up. And this lets me modify the name. The important part is that you remove all the quotation marks because then the JSON will be invalid. And you can't escape it with a backslash because helpfully, because there might be a path somewhere, all the backslashes get
Oh,
transformed into
yeah.
this. for the benefit of the Windows users.
Yes.
But yeah, so we make a little indirection here, and when the transform comes, and the transform itself just inserts the begin and end, and replaces all the calls with the calls to the new ad hoc symbols that we create here in the for each line. And yeah, it's as simple as that. And then we run it with the record function and with the compute enabled, and that's all there is to it. So
Yeah. Plus the ability to run to profile from one symbol to another symbol. So once you have the trace, you can then focus it on a subset, like focus the profiling on a subset of the whole trace, on a subset, on a chunk of the whole trace. And then
right.
we are probably iterating on the syntax there. Probably there will be the symbols themselves are the best. Sorry, not the symbols, the outputs are the best kind of indexing to the thing. They're very natural. Also because you see
Right.
them in the trace, in the profile. So if you want to dig and like dive and not profile everything, you have them in front of you. So it's very easy to know from where to where you want
Yeah.
to run the thing.
I mean,
So yeah,
just
I mean,
like
I think it's
going
awesome.
through the trace, finding the index, right?
Yeah, yeah. So I think it's awesome because it solves a typical problem of staring at the CUDA stream and like not knowing where it maps because uh, you cannot just go vertically. Like in the worst case, you look up and you find what called it, but that's bad news because it means that your CPU is not scheduling things fast enough. Your kernels should be always on the right of where the CPU is. And so if you're doing things properly, your kernels will refer to something that like was launched a while back. And yeah, there is a possibility to create connections and so on. I've seen that I don't know if the Chrome trace has it or Insight has it. Like the link, there's a you click on something and you have the call
Yeah,
site.
I think that's the you need insight for that.
Yeah,
But
there's
now you
Insight.
have at least the connection between the different lines in the trace on the CPU and on the GPU.
Yeah, because
So
you have the same names and also you capture things at a high level enough. So you have a full op and not or a fuse kernel that will may lead into some other calls or something. A symbol may kind of be broken down into others. But if you stay high level enough, it will make sense. But more importantly, you don't need even to make the connection because you have it there in the stream. So you have the kernel or kernels, and then the thunder symbol right above it, which is I think it's a massive. I know it's like 100 lines of code and it's a simple thing. It makes me wonder how many other things of this nature we could build around the trace because it's really made to let you navigate things in this way. So I've
right,
always had the itch of building a text a text UI, terminal UI that has maybe the source code on one end and the trace on the other, and lets you kind of navigate one or the other, or just the trace and something else. But of course, zero time, dubious talent, and so I probably never get around to do it. But yeah. Anyway, this was
yeah,
super fun. Yeah, I can't wait until this lands into Thunder. And yeah, and maybe next week we'll do something else, and we'll build the PyTorch talk to bit by bit. Plus, there were other things I will just
right,
show there. But yeah,
yeah,
awesome,
super
nice. So back to having fun.
good. Yeah,
Have a great weekend, Thomas.
yeah. You too, Luca, and everyone out there.
Bye bye.
Bye.